Lecture 4, example 0.2. A battery with a terminal voltage of 9 volts is connected to a circuit consisting of 4 20 ohm and 1 10 ohm resistors, all in series. Figure 10.13. Figure the battery. Assume that the battery has an eligible internal resistance. A. Calculate the equivalent resistance of the circuit. B. Calculate the current through each resistor. C. Calculate the potential drop across each resistor. D. Determine the total power dissipated by the resistor and the power supplied by the battery. So this is the figure. So the equivalent resistance of the algebraic sum of resistance. So A, yung atong giatan na ng resistors from R sub 1 to R sub 5, we get 90 ohm. And B, the current towards the circuit is the same for each resistor. So this circuit is equal to applied voltage divided by the equivalent resistance. So I is equal to V equals resistors equals to EQ equal to 9 volts over 90 ohm is equal to 0.1 ampere. So C. So we get the potential drop across each resistor can be found using Ohm's law. So V sub 1 is equal to V sub 2 is equal to V sub 3 is equal to V sub 4 is equal to 0.1 A times 20 ohm is equal to 2 volts. And V sub 5 0.1 times 10 ohm is equal to 1 volts. Okay. V sub 1, i-add na to from V sub 1 to V sub 5 is equal to 9 volts. Note the sum of the potential drops across each resistor is equal to voltage supplied by the battery. And D, the power dissipated by the resistor is equal to P is equal to I squared R. P sub 1 is equal to 0.1 A parenthesis squared times 20 ohm is equal to 0.20 watt. P sub 5 is equal to 0.1 A parenthesis squared times 10 ohm is equal to 0.1 watts. So, see, P dissipated is equal to 0.9 watts. Itong i-add sila. And the P source is equal to 0.1 times 9 volts is equal to 0.9 watts. Example 10.13. Example 10.3 rather. Two resistors R sub 1 is equal to 1 ohm, R sub 2 is equal to 2 ohms, and R sub 3 is equal to 2 ohms are connected in parallel. So, the parallel connection is attached to a V equal to 3.00 V voltage source. A. What is the equivalent resistance? B. Find the current supplied by source of the parallel circuit. Circulate the currents in each resistor and show that these add together equal the current output of source. D. Calculate the power dissipated to each resistor. And E. Find the power output of the source shows that P equals to total power dissipated by the resistors. So, solution A. So the total resistance for parallel combination of his resistor is found using equation 10.3 and then no values gives. So ano siya? Is equal to R over R sub 1 plus 1 over R sub 2 plus 1 over R sub 3 to the power of negative 1. We solve the values, we get to 0.50 ohms. B. Total current can be found from Ohm's law. Substituting R EQ for the total resistance, this gives I is equal to V over R EQ is equal to 3.00 volts over 0.50 ohms equal to 6 ampere. C. The individual current R is leakage in Ohm's law since other resistors gets full voltage. So I sub 1 value is 3.00 volts over 1 ohm is equal to 3 ampere. Sa I sub 2 pod with the same formula and the I sub 3. So we add I sub 1 plus I sub 2 plus I sub 3 is equal to 6 ampere. B. Good. Since each resistor is exposed voltage, thus P sub 1 is equal to V squared over R sub 1. We said that the value is 3.00 volts, parenthesis squared over 1 ohm is equal to 9.00 watts, and the P sub 2 we have 4.50 watts, P sub 3 with 4.50 watt, and then E, the total power can also be calculated in several ways. So now the formula P is equal to I, V is equal to IV equals such that the values 6 times 3 is equal to 18 watts. Example 10.6. So find the current flowing in the circuit in the figure 10.29. Muna siyang figure. Solution. So applying the junction and loops rule, solve the following three equations. We have the three equations are required. So junction C, I sub 1 plus I sub 2 is equal to I sub 3. And loop A, B, C, D, this one, we have V sub 1 minus V sub 3. And the loop C, D, E, F, C, may siya random. Next circle, we have V sub 2 plus V sub 3. So simplify the equation by placing the unknown on one side of the equation. So junction, 0 man si I sub 1, I sub 1, I sub 2, and I sub 3 equal to 0 man. So 0. Loop. So 3 ohm minus 8 ohm is equal to 0.5 volts minus 2.30 volts. Si loop CDFC, we have 0.6 volts plus 230 volts. So simplify the equation. The first loop equation can be simplified by dividing both sides by 3. The second loop equation can be this one. Second loop equation can be simplified by dividing both sides by 6. So we have here 0 gap on C junction C. 3 ohm minus 8 ohm is equal to 1.8 volts. And Philip CDFC, 8 ohms plus 1 ohm is equal to 2.9 volts. The results are this one. I sub 1, I sub 2, I sub 3. We have I sub 1 0.20A, I sub 2 0.30, and 0.50A. Example 10.7. So find the current flowing in the circuit in figure 10.30. This is the figure 10.30. Solution applying the junction rule yields the following three equations. We have one unknown and one equation is required. So loop A, B, C, D. So kanina mo siya si loop A, B, C, D, A, B, C, A, C, D. Is equal to 0 and I parenthesis R sub 1, R sub 2, R sub 3, add na to and multiply the arms. We have V sub 2 minus V sub 1. So here si V sub 1 na si V sub 2 minus V sub 1 dire kaya ano siya over 1 multiply. So we have here, so 24 volts minus 12 volts over 10.0 ohm plus 30 ohm plus 10 ohm is equal to 0.20 A.